In this example from the chapter 5, we have to find dy by dx given that y raised to the power x plus x raised to the power y plus x raised to the power x is equal to ab. Now, for doing this, what we are going to do is to consider, say y is equal to the first, I'm taking this as a uv, right? The first as u is equal to y raised to the power x. Then I'll consider the other as v is equal to x raised to the power y. Then say w is equal to x raised to the power x, and we are going to keep this as it is. Now, therefore, I can write this function as we can replace this equation with u plus v plus w is equal to a raised to the power b. Now, clearly differentiating this both sides with respect to x, if I differentiate this with respect to x, what you're going to get is du by dx plus dv by dx plus dw by dx. And as you know, this is a constant, like if I say that 3 raised to the power 5, it is a constant, and the differentiation of constant is 0. Now we can figure out that in order to find dy by dx, we have to differentiate each of this. That means we have to find the differentiation of u, v, and w. So let's begin with the first part. That is u is equal to, this is u is equal to y raised to the power x. Now clearly we'll be applying log here. So log u is equal to x log y. This is log y. Now applying differentiation with respect to x, for log y it's 1 by u, and for u it is du by dx is equal to, we are applying a product rule here. Differentiation of x is 1 and log y is as it is. So log 1 into log y plus u dash, we have done u dash v plus uv dash, that is x as it is, and differentiation of log y is 1 by y, and then we'll also write for y it is dy by dx. So now we can say that we'll get du by dx, and du by dx will be obtained by transposing u to the other side. Well, clearly u is this, that is y raised to the power x. So we'll write this transposing y to the other side. It will be y raised to the power x times log y plus x over y dy by dx. So we have obtained the differentiation of u. Now, let's say if I do the differentiation of the other, that is v. So we have v is equal to, we are given v is equal to x raised to the power y. Same way, we'll be applying log on both sides. So log v is equal to y log x. So differentiating again with respect to x, we'll get what? 1 by v dv by dx. Applying product rule here for differentiation of y, it is dy by dx and log x plus y times differentiation of log x is 1 by x. And for x, it is 1, so we don't write. Now we can figure out that we can get dv by dx. If I transpose v to the other side, v is this. So I'll be writing x raised to the power y times log x, or we can first write dy by dx times log x plus y over x. So we got this also. So we got two equations here. That is first being this and the second being this. Now, if we continue solving, we will now will be finding out for w. So I'm writing w here. For finding w, I'm writing this w is equal to x raised to the power x. Here also we'll be applying log. So it is log w is equal to x log x. For w, it's 1 by w, and dw by dx is equal to log x. Now I have need more space, so let's push it a bit above. Yeah. So if I find the differentiation of x, it is 1 log x. That's the product rule. For x, it is copied, and log x, it is 1 by x. So now if I transpose w to the other side, so it's dw by dx is going to be w is what? W is x raised to the power x. So that is x raised to the power x times this is 1. So 1 plus log x. But we need dy by dx, right? So let's say if I get dy by dx. So from here, that means if I plug in these values, like replacing this with its value, what we are going to get in this. That means first I'm replacing du by dx with this, which is y raised to the power x times, and I'll open the bracket here also. If I open the bracket simultaneously, is y raised to the power x times log y plus y raised to the power x times x over y dy by dx. This is u. And now I'm replacing dv by dx here, which is from the equation 2. And if I open the bracket simultaneously, it's going to be x raised to the power y times dy by dx log x plus this into this, which is x raised to the power y over x. And finally, we have dw by dx, and dw by dx is this. That is x raised to the power x times 1, and then x raised to the power x times log x, and that is equal to 0. Now we know we have to find dy by dx. So we'll be isolating dy by dx. I can see dy by dx is over here once. Then we have dy by dx over here twice. So we'll be taking dy by dx common. Let's say if I erase this portion now. So if I take dy by dx common, what we are going to get is, we are going to get this, which is, if I apply laws of exponent between this and this is y raised to the power x minus 1. This is y raised to the power x minus 1 times x. And from here, we are going to get x raised to the power y times log x. Now transposing the remaining on the other side. So on the other side, we have what? This. So if I write this, this is on the other side, it will be minus, let's say minus common. So y raised to the power x log y. So we have taken this outside, right? We have taken this common, we have taken this common, and the remaining part are these, this. So we can say that here we can again apply the laws of exponent. As you can see here, in between these two terms, we can apply laws of exponent. So applying the laws of exponent, this will be x raised to the power y minus y 1 raised to the times y, right? This is y raised to the power x raised to the power y minus x raised to the power 1. Now we have left with this, which is plus x raised to the power x plus x raised to the power x times log x. Now in the next part, in order to get dy by dx, we'll be dividing with this. That means we need to divide. In order to get dy by dx, we'll be dividing with this. Say if I divide like this, so we can say dy by dx will be this only.